Here we are on day 17. And just fair warning, I have a bit of a headache. So I might end up bailing out if it gets worse. Hopefully not, though. All right, pyroclastic flu. Alternate exit. The ground is rumbling almost continuously on strange valves. Definitely warmer here, though. Tunnels eventually open up to a very tall, narrow chamber. 5 types of rocks have peculiar shapes. Tetris. Rocks fall in the order shown. First the minus, then the plus, so on. Once the end of the list is reached, the same order repeats. Blah, 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 blah. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. Quick scan reveals the effect of the jets of hot gas have on the rocks as they fall. Your puzzle input. For example, suppose this was the jet pattern in your cave. Right? I'm going to scroll to the bottom, make sure that this is my puzzle input is going to, yep, just going to be a bunch of that. Okay. Back up. In jet patterns, blah means a push to the left, while a push to the right. Pattern above means the jets will push a falling rock right, then right, then right, then left, then left. Sure. At the end of the list, it repeats. The tall vertical chamber is exactly 7 units wide. Each rock appears so that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room, or the floor if there's one. After a rock appears, it alternates between being pushed 1 unit and then falling down 1 unit. If any movement would cause any part of the rock to fall into the walls, floor, or a stopped rock, the movement instead does not occur. If a downward movement would have caused a falling rock to move into the floor, or an already fallen rock, the falling rock stops where it is, having landed on something, and a new rock immediately begins falling. All right. So it's 7 wide. Did they say how tall it was? Each rock appears. Oh, and its bottom edge is 3 units above the highest rock in the room. Okay. Or the floor. After a rock appears, it alternates between being pushed by a jet of hot gas. The direction indicated by the next symbol of the jet. Falling down, yep. Okay, so right, falls, right, nothing, falls, right, nothing, falls, left, falls, and you're in place. New rock begins falling. Jets of gas, yeah, okay. The moment each of the next few rocks begins falling, you would see this. Okay. Sure. Okay. The tower of rocks will be 3,068 units tall. How tall the tower will get after 2,022 rocks have stopped, but before the 2023 rock begins falling. So you have to run for 2022 rocks. How many units tall will the tower be? Okay. So these are our rocks, and they come in this order. Rocks is new string array. New list of string array. New array. Right? So that's you. And this is this. Okay. And this starts here, so it's this, 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 right? How many shapes are there? There's supposed to be 1, 2, 3, so that's the L. How many shapes are there? I thought there were 5. 2, 3, and then this. And then the block, right? So this. Right, and then we have this. Which is that. So those are the rocks. Well, let's see. So the air is data 0 to array. Well, that's just going to be a character array, right? Okay. And we need to fall 2022 rocks. Okay, so let's say rock number 0. We need to keep track of basically a growing list of 7 wide. And then we know it's going to grow at least 3,000 in this case. The only thing that's different is the pattern. We're always doing 2022. What is the best way to represent this? I guess the board is going to be a new character array of, let's see, character array, I think, like 10,000 by 7. That's where we're going to start, right? Highest point is that's that. We just assume we have a floor there. And then this is going to be character. Is that the right answer? Boolean's probably fine. So the highest point, 99.99. Right, so while rock number is less than 2022, apparently we're going to do a for var rock number is 0, rock number. Okay. bottom start is, let's see, highest point minus 3, is that right? I think that's right. Highest point minus 3. Let's push to the right, on the right. 7 units wide. Each rock appears so that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room. Let's see, so bottom Y, left X is 2. So the piece is going to be rocks of rock number mod 5, right? So basically what we care about is we need to do collision tests going backwards up the rock while we do this. So while true, if bottom Y is equal to 99.99, we break. Right, that's fine. We don't have to test for collision yet. We just want to know if the bottom Y has reached the end. What we really want to see is let's do, they gave us details for 1, 2, 3, 4. Let's do 2 rocks just to start. 22 is what we really want. We need to do an intersection check. So, we need to go right first. Or left. Okay, so we need, this is air movement, air index. You'll start out at 0. So if air of air index is equal to right, otherwise, so if we're going right, then if left x plus, so you're 0, so you're at 2. So 2 plus 1, 2, 3, 4, 6, right? Would be 6. So if left x plus piece 0 length minus 1 is less than If you're less than 6, or we can take the -1 away and just say less than 7, then left x plus plus. If left x is greater than 0, left x double minus. Okay, so that is the error. Now we try and drop. Now we say bottom y We actually need to do a collision test here too, right? We also need a collision test here. Collision test. We'll get that in a minute because I think we're just going to write a generic collision issue. And then we're going to say if collision of our piece and our left x and our bottom y plus 1. So if there's a collision, then we're done. All right, then we need to record final location, right? Now I want this in here. So if not collision, piece left x plus 1, bottom y, and we do that, right? And then we say if not collision, piece left x minus 1, bottom y. These can actually be combined. That's fine. Those can be combined. Okay. So all we need now is collision. Bool. Collision. You're going to be string array piece int left x and bottom y. Okay, so return true for the moment. That's fine. Okay, so if you collided, then we need to record your final location, which is for each string in piece row in the piece. We need the board at left x and then we'll do for int idx is 0, idx is less than row length, double plus idx, right? And then we'll say if piece of, if a row of idx is equal to a rock, right? Then we're going to say board at so this is bottom y, right? So var y is bottom y plus piece length minus 1. Right, y double minus. Board y x, y left x plus index is true. comma. We should do it the other way, right? So we're going to do x comma y. Why not? Y comma x always makes people feel weird, myself included. Okay. So bottom y, whoops, this is supposed to be minus and plus because we're going up. Okay, so that records the final location, and then you're done with this. Print board. Print the board. And probably highest point. So when we're done here, we want to know potential, let's see, highest point on piece is going to be, actually, it's going to be this. If the highest point is greater than the highest point on the piece, then the highest point is the new highest point on the piece. Then you can break out, print the board, right? Void print the board, which is a bool board, and then int highest point for y is highest point, y is less than 10,000, y is less than 10,000, that's fine. Double plus y. We're going to do a console write line of this, and then we're going to do board of maybe I do want to go backwards. I can't do this, right? Oh, I can. No, I can't do that. Right. Our spaces is x is 0, x is less than 8, double plus x, whoops, less than 7, double plus x, space is append, char, space is append, sure, whatever. Board x, y, you're that, otherwise you're that. Right, is that how they print it out? When they're done, yeah, that's how they print it out. Okay, console write line, this space is that. So that's the board. Let's see what happens here. Besides failure to compile, because I'm missing syntax. That's surprising. Board. Space is append, board x, y, that. I bet append is not doing what I think it should be doing. That is certainly not what I expected. All right, so let's do one rock. And let's print the board every time. Apparently, we also want to print the board border. All right, console write line 1, 2, 3, 4, 5, 6, 7, and then a console write line. Okay, so we start there, and we started there, except we didn't move enough. Yeah, that didn't move enough. Why not? Oh, because of course we haven't written collision. I'm an idiot. Everything collides. So we need the board here as well. Of course. Board. Board. And board. Okay. So how do we determine collision? Well, we look at the board and we say for x is left x, x is less than left x plus piece length, piece 0 length, right? Because that's x. Double plus x. And y is bottom y minus piece length plus 1. Y is less than or equal to bottom y. No, not like that. We need to do these from 0. Yeah, we do these from 0. We do the math elsewhere. Y is less than piece length. Double plus y. If board at left x plus x, comma, bottom y minus piece length plus 1, return true. I think that's it. I think that's it. All right, so that's not what I expected. Okay, so we start here with basically a completely empty board, right? Yep. Okay, so left x is 2, bottom y should be 9996. And then our piece is this, okay? So while true, we're gonna print the board. That'll give us the flat board, right? That'll give us the flat board. So we're not there yet. We did not move the error. Yeah, we don't want to do it like that either, though. Error index is error index plus 1 mod error length. Okay, that's fine. Okay, so there's our piece, there's our board. We're not there. We're going to move right. So left x, piece length is 4. So 2 plus 6, 2 plus 4 is 6. That is less than 7. And board piece left x plus 1 bottom y. So let's step into collision. Okay, so our board is empty. Our piece is this, right? Our left X should be 3 now. And the bottom Y is 99.96. So we should end up out of this with a false because there's nothing to collide. Okay, good. So we go right. Okay, so air index is now 1, fine. So we don't collide yet. Print the board. Yeah, that's true. We've been printing an empty board basically because yeah, and we haven't been moving. All right, I get it now. We didn't move bottom Y. Hmm. Well, that's interesting. Okay, that's not what I expected either. Oh, because we break out of here because we hit the bottom. Which is we should just do this and then record the piece. Right. So there you go. There's that, and then there's that, except that is not, yeah, that's not great. Let's look at this first record. So the bottom Y ended up on 99.99. The left is on 3. That makes sense, right? For each row in the piece, okay, so we're going to start at 99.99. That makes sense. So for each row in the piece, so that's this. If that is there, then 3, comma 99.99 is true. Okay, that's okay. So that's how we got our first piece here, right? And then that's good enough, right? So the highest point on the piece, yeah, is 99.99. That's fine, 99.99. So you stay there. Diagnostic tools, nobody asked for you. Go away, nobody ever wants you. Print the board, all right, so that gives us that as our board. That's fine. So rock number 2. So again, we're gonna start at 99.96. Isn't that interesting? 996. 99.99. I guess the highest point here should actually be 10,000. I don't think that's going to change anything here. It's really not. Because you need to be, we need to start 10,000, 99, 99, 99, 99, 97. So this actually should be, I don't understand. I thought it was 3 above. 3 units above the highest rock in the room or the floor if there isn't one. So that's actually 4 units above. That's not 3. That's fine. Rock number, mod 5. Okay, so that's okay. All right, so we hit that one. Let's go back here again for our next rock. So this is rock number 1. So left x is 2, so bottom y now is 99.95, right? And then our piece is 3 tall now. Okay, I'm gonna double check and make sure these are all the same height always. 3, 3, 3, 1, 1, 1, 1, 2, 2. Okay, there we go, good. Okay. This probably needs to be, actually 99.99 is fine there because that is where we want to come to rest. Okay. So we're gonna try and go left. Is that right? Pushes right, nothing happens, falls 1, jet of gas pushes left. So you're gonna go left, right, you're gonna go left 1, you're gonna go down 1, you're gonna go right 1, you're gonna go down 1, you're gonna go left 1, you're gonna go down 1, you're gonna go right 1, and then you're gonna stop, and that's what it should look like. Okay, so there's the left 1. So we don't collide. Down 1. Left 1 again. That's weird. That does seem weird. Hang on here. Okay, so our air index is going to start at 0, of course. But we should use, let's see, 1, 2, 3, 4, 4 jets of gas, except this 99.99 thing, you know what? Doesn't happen here. Shouldn't happen here. We have to say bottom Y come to rest on the ground, or we run out of things. Okay, that should be better. But still not good. It's probably, yeah, all right. The first one lands in the right place though, right? 2, 4, 1. 2, 4, 1. Yeah, 2, 4, 1. And so we use 1, 2, 3, 4 jets of gas. So our air index when we come back should be 4, because of course we start on 0. So our air index is now 4, good. That puts us in the right air, because we were definitely wrong before. Okay. So we start here again. So we're gonna start at 99.95. We're gonna go left. We're gonna drop. We're gonna go right. We're gonna drop. We're gonna go left. We're gonna drop. We're gonna go right. And then we're gonna drop. Our bottom Y now should be 99.98. But we should break out because of collision. So let's step in and make sure that's true. Because here you're gonna be 99.99. So we're going to start with x of 0, y of 0. Bottom y, quick watch, please. Where's quick watch? Shift F9, 99.97. That makes sense. So we should have no collisions on 9997. We should have no collisions on 9998. Wait a minute. This is 99. This is somehow Y didn't get factored into this, right? Still 9997. All right, great. So this should be plus Y. Okay. So let's see a break here. Got the break here. Let's see the break. So the bottom Y is 9998. Okay. So the highest point on the piece would be 9996, right? So that's what Y is. This is going the wrong direction. That's the problem. Okay, so that's what it should look like, right? You're over 2. You're basically in the middle. Right, you're in the middle. So let's drop the third rock. Let's drop, how many rocks do we see here, right? So there's the third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. All right, let's see the third. So the third should look like this, right? So let's do 3. So it's looks like that. Yeah, that looks right. That looks right. All right, let's do all 10. And then we'll trace through and make sure that we understand how they're all supposed to look. Okay, so let's do 10. We'll go back up. So there's 3. All right, so here's 4. So there's 3. Here's 4. That looks good. Here's 5. That looks good. And then here's 6. That looks good. And here's 7. That looks good. And then here's 8. Yeah, that looks good. So then here's 9. Should look like this. And it really does look like that. And then there's 10, which should look like this. All right, I'm convinced. So the answer is 3068. Right, so let's drop all the rocks. Right, and then let's stop printing boards. And then we'll say return 10,000 minus highest point. Well, 10,000. 2802. 2802. 3068. 3,068 units tall. Now, when we print the boards, we're using the tallest thing to tell us how to print the board, and we're not missing anything off the board. Right, if we were to print the board highest point minus 1, that should just show us that every time the top is there. The top is there. Man, this all looks correct. That's what's killing me about this. And then here's 17, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's 17. Highest point on the piece is bottom y minus piece dot length plus 1. Y is the highest point. If the highest point is greater than the highest point of the piece, then that's the new highest point. That highest point, right, 2802. 2802. I don't think I missed anything because we rotated through the rocks correctly. And we should have rotated through the air correctly. Because let's do like 30 rocks, right? And our air index should be your 40 characters long. So you should rotate through every 40 characters, right? 0, 1, okay, well that was dumb. But here's 39 and 0. So the air index is rotating around correctly. Right, we basically have tested the collision logic of everything by looking at those first 10 sets of rocks. They want to know how tall the tower will get after 2022 rocks have been stopped, but before the 23rd rock. In this example, the tower of rocks will be 3,068 units tall. I don't understand how we've gotten this wrong. I honestly don't. 53, not rock number. Is it 2022? Let's make sure. 2022. So we do 2022 rocks. 2802. I just don't understand how we've gotten this so wrong. How can we be off by 200 rows? So like this one, we saw it got slotted in right here, which is clearly where it should have been. Hmm. Well, that one ended up there. Um, hmm. I don't understand, but I'm tempted to just try the puzzle input and just let it do its thing and see if I get the right number anyway. 3233. Nope. Well, I guess that's not a surprise, because if you tell me I'm supposed to be 3,068 units tall, then I'm supposed to be 3,068 units tall. My problem is, I guess I could update this, print board, do console.clear, right? And then if you have a piece, and then that would be the piece int piece left x int -1 int piece bottom y is -1. Let's see. Top row is piece equal to null. It's this. It's not that. Come on. It's this. It's that. Otherwise, it's the minimum of that and piece bottom y minus piece length plus 1. So let's try, we're not printing the board there, we're going to print the board here, right? Print board, highest points, piece, left x, bottom y, and then thread sleep 500. Let's do 3 rocks. Let's do this more like 250 maybe. Let's see what happens here. Okay, so the print is not quite doing what I wanted. Highest point -1 and piece bottom y minus the number of lines in the piece plus 1. Dumb. Right, so that should be us watching the pieces fall. Original bottom y is bottom y. Nah, that's fine. Okay, so what we want is to now actually print the piece here as well. All right, so we should say, if you're rock this, otherwise, let's see. Let's do this. If board xy, then spaces plus equals a rock. Otherwise, if, let's see, x is less than or equal to piece left x, and x is greater than or equal to, less than piece left x plus piece 0 length, and y greater than or equal to, let's do this, piece top y. This is also only if we have a piece. Piece top y is going to be this. Piece top y. Piece equal to null, 0, otherwise that. Okay. Otherwise, if we have a piece and y is less than or greater than or equal to piece top y, and y is less than or equal to piece bottom y, and piece sub x minus piece left x, y minus piece top y. If you're equal to that, what's the problem here? Piece is not, oh yeah, not right. These go y and then x like this. This all has to be part of one big. Is that gonna work? Really not. Oh, left the old line in there. Oh, that's interesting. We didn't actually place that last piece? Oh, no, we just didn't print it. Right, and then we just print the board when we're done. Actually, we'll do -5. Just to make sure we don't actually have anything hiding up there. So our height is 6, right? 1, 2, 3, 4, 5, 6, which looks correct. And that is what the 3 position should look like, if I remember correctly. Right? That's what the 3 piece looks like. I'm really unclear how this is doing this. Let's do 10 rocks again. Actually, we could print this again here, right? That way we're seeing it move. Actually, keep those there, but comment it out. Interesting. Without a thread sleep in there, we can't see any of them. Of course, my using went away. Of course it did. Cut it. Like a console flush, maybe? Nope. Just not giving it enough time to show. Okay. Now we can't see it anymore because we've we've lost the number of Okay. Well, I mean, I really don't understand what's going on here. When we get here, sleep for 1,000. I need to get this back to the size it used to be. Let's do 50, 50, 5,000. I don't see anything wrong. Wait, why? When this was here like this, no, we definitely have a collision. Definitely have a collision problem. Collision. Board. Piece. Okay, so given the left x and the bottom y that you propose, if the board of left x, we're missing, we need to look at the piece. If piece sub y sub x is equal to this and that, that's the problem with the collision. $30.68. That's what it's supposed to be, right? $30.68. Bless America, we had to watch it to see it actually happen. Okay, well, you know, sometimes that's why you gotta print it out. 3100. 3100. Let's go. Okay. Elephants are not impressed by simulation. Demand to know how tall the tower will be after a lot of rocks. Only then will they feel confident enough to proceed through the cave. In the example above, it would be that many units tall. That's a lot of rocks, right? So that's 1 and 12 zeros. One and 12 zeros. I mean, in theory, same thing, right? Where's the 10,000s? No 10,000s. Oh, there is 10,000 here. Long max y. You need to be long. Max y. Is there 10,000 anywhere else? No, not here. Except that's not sort of the maximum. This is the maximum we think. So we do this like this. 1.5 billion, because it's 1 billion rocks. So let's do 3 billion. 3 billion times 7 is 21 billion booleans. I don't know how optimized that's going to be. I guess we're about to find out. And then your 1 billion rocks. Rock number mod 5 is going to be long. Int. That's fine. So this is going to be this. Oh, not collision, sorry. It's printboard that actually wants that number, isn't it? It's printboard that wants that number. This has to be long. Actually, that can stay int, because this is long, so this value is going to be long. And as long as the index on the array can be long, then that should be okay. So if bottom y is going to be this, except it's not that, it's actually this. And then that's this. Sorry, that's this. And that's that. Out of memory. Yeah, okay. Out of memory. Is there an easy way for us to be able to represent this? Don't care about you. Do care about you. This is our out of memory right here, right? Array dimensions exceed supported range. Let's do a little Googling here. Give me a new edge window. Maximum number of items in the C# array. Maximum size of an array is 2 gigabytes. 64-bit, you can avoid the size restriction by enabling the GC allow very large object configuration. However, the array limit will still be limited to a total of 4 billion elements. So we could do this with with we could have a byte array instead of a Boolean array, right? Let's make sure that that works before I go to all the trouble to convert that. New byte and 0 long. Array dimensions exceed supported range. Oh yeah, I have to do, what did it say? GC allow very large elements, so how do I turn that on? .NET Framework. Is it supported? .NET Core. How's it done? Yeah, I don't know how it gets set though. Single dimensional arrays cannot have more than 2 billion elements. It's one dimensional. Create is interesting. All right, well, let's try that. Okay, I guess that's true. So we can't have any one dimension bigger than 2 billion. Okay. So that'll work. So if our board looks like this, max Y, lower bound of a dimension, okay, so max Y is going to be board get, let's see, you need to be long, get board.get, upper bound, 0 times board get upper bound of 1, right? get board value for this board and X and Y. We'll get board value for this board, and then int X long Y, is that right? Let's see, so what we really want is we want can I do this? No. Let's see. Long. So total index is going to be y times x divided by 8. Let's say y times x. Array index is total index mod divided by 8. Right. And so index 1 is going to be then index 1 is going to be array index. Fuck it, I don't care. I'm just going to hard code it. Right. Return board index 1, index 1, index 2. And mask is equal to mask. Now we need to set the board value. We'll just say max y. We're going to put max y up here. Oh, yeah, actually, I don't. This is fine. The index, yeah, I did this wrong. That's okay, though. We'll come back up here. All right, so the index is actually y. All right, the index is actually y because right. Y. So we need to update collision. We're going to do this with 2 rocks again. So this is set board value left x plus idx y true. You need the board too, right? Of course you need the board. So collision, this needs to be updated to this board. And then this is get board value for this, for the board. And that's x, and that's y. Set board value is a void, not a bool. Okay. Index out of range. Index is outside the range. 43. Let's see what we did wrong here. Obviously the math here was incorrect. Okay, so if I want 0 and 99.96, which is fine, but also we should be using max y. Max y. Max y minus 1. Highest point is max y. We print the board. Highest point is along. And highest point is max y. Highest point on piece is bottom y. Why is bottom y a uint? Highest point is a uint. Long. Bottom y is now a long. Max y minus the highest point. Okay, still out of range. What am I doing wrong here? So x is 0 and y is big number. So these are backwards then. Y, this should be y mod 2. Is that right? This is y divided by 2. Still. X is 0, y is that, so that's 0, and then that should be half of that. And it is. So board why is it 105.64? Is that why? So the board is that and that. 105.6413696. That's not what I asked for. I asked for 1.5 million. 1.5 billion. Okay, well, let's try this then. Wait a minute. That's more than a billion. That's a trillion. Okay, what's the square root of a trillion? A million. But a million times a million is a trillion. A trillion bytes. Right, so if I were to try and new this up with a million by a million array, out of memory, yeah, that's too big. So obviously we can't just record it. So I think the only way that this is going to work then is we need to roll off data that's no longer reachable. How am I going to do that? How am I going to roll off data that's no longer reachable? How do I know data is no longer reachable? How do I know something can no longer get in? How do I know something is no longer reachable? All right, I'm gonna take a quick bio break. I'll be back in I'll be back in a couple minutes. All right, I think I have an idea. I think the answer for this is that we know once something is unreachable based on in each of the 7 columns, whatever the lowest occupied point is the lowest reachable point. So if you were to draw, like, let's say this, right? The simplest answer would be the bottom, right? If we put the ground at the bottom, then the lowest reachable point of all of these is the bottom. So now let's put we put that part there, and still the lowest reachable point is here because these are here and this is here. But now if we had this, for example, let's say we had this. Now this is completely unreachable, right? The lowest reachable point is now this row because of these two, right? So if we were to just run across each of these lines and basically say, okay, who's got the lowest reachable point? And that's when we can sort of roll data off of the list. And so as we roll those rows off the bottom of the list, we can basically just keep track of the number of rows that we've rolled off the list. That way we don't have to count the whole thing, right? So what's the easiest way to do this? Right, I think what we want is now we're going to have a board class because it's going to need to have right, we're going to need something like set. We're going to need something like is set, right? And then we're going to want to do garbage collect. And so what is the easiest thing to do? Ow. We're going to start with, so each row is going to be each row can be our Boolean array. That's fine. So we're going to start out with a list of Boolean array rows. And then we're going to do what is the right answer here? Top row, going to be $4 trillion, right? Because we're going to take this number, we're going to take this number, and we're just going to turn that 1 into a 4. All right, so that's our top row. And we're going to start with a single Boolean array of true, 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 right? That's our floor. Yes, you can simplify that. Okay, so that's our rows. I don't know what the constructor looks like yet. So then we will say, so the is set is going to be if y is less than top row, then we know you're not there, right? Because we only have one set of data. Let's see. So target Y is going to be 4 million. Let's see. 4 million minus Y. The top row minus Y. So that's my target Y is the top row minus Y. Except we're going to want the right. Let me top row minus Y. Okay. And we're also going to say if rows length count, apparently. If there's not enough data, then we haven't recorded you either. Otherwise, we're going to say return rows of target Y of X, right? Can't convert from a long to an int. Sure we can. We'll worry about set here in a second. Garbage collect in a second. Okay, if Y is greater than the top row, throw new invalid operation. Try to set for Y equal to Y exceeds max row equal to top row. Top row is equal to top row, right? Target Y is top row minus Y. While rows count is less than target Y, we're going to add a new row. False. So 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5, 6, 7. Okay, good. And we're going to say rows at target Y at X is true. So that will expand it. We shouldn't need to garbage collect at this point. So collision with a board. Actually, let's not do that. Let's do this. Collision. Piece. Left X, bottom Y. I guess we don't really need max Y there anymore, do we? That's fine. So we need collision there of a piece with a left X and a bottom Y. So we've got get and set already. And then we could print the board. We'll come back and finish that in a minute because we'll probably want that, but not sure yet. We might not want it. Okay, so the collision here is, let's grab the collision logic and just adapt it. Collision. Print board. I guess this is all based on is set, really. Is set. Bottom Y is long, so piece length 1 Y. So that should be okay. That collision should be fine. Is set and set. So we don't need you. What we need up here is no board printing. And that's not the board. So the board is a new board. This highest point isn't tracked here anymore. We need the highest point. That is the top row. But we don't actually care about the highest point. What we care about is total rows, right? Atomic long. Rows consumed is going to be that. So at the end of this, we're going to return the board rows consumed. The highest point minus 4. So we do need to know the highest point. Public long, top row, top. How about we do it like this? And you start out with this value. Top row, top row, top row. So every time we have to add a row, we also have to decrement the top row, right? Oh no. Shit, that is not what I meant. I don't want you to be top row, I want you to be bottom row. Actually, top row is this. All right, cut it up. So if that's the top row, actually, I was correct. That's actually the bottom row. The top row is, and rows consumed is the same thing. So this is minus the top row. Top row is bottom row minus because we don't want to count the floor. All right, so the top row is the bottom row minus rows count. Rows count. So that's the top row. It's rows consumed. That's fine. Exceeds bottom row, which is equal to bottom row. So this logic now looks incorrect. So if you're greater than the bottom row, you're not there. Bottom row minus y. Okay, that's fine. Right, that makes sense. Okay, back up here. I'm just going to delete all of this because this is all wrong anyway. We're about to rewrite this and maybe reuse it. Right. All this stuff sits in here, sits in run. So the air index has to start at 0. Your int air index starts at 0. Rock number less than rock count. This has to be long anyway, right? Long rock count. Rock count. So you need to be long. Rock count, not round count. Left x is 0. Bottom y is the highest point. minus 4. So that's the top row. I think that's the top row minus 4, right? Top row minus 4. Rocks, you can be rocks, your list of string array. You can be static. Yes, you can be simplified. So that's air. You can't use air because it's not here. Our board is a new board for the air. So we need a character array for the air. All right. Air. So that's air. That's rocks. Kind of convert from a long to an int. Int. Okay. Oops. Don't think I need that anymore because the collision will handle it because we put the floor at 4 trillion. We don't need to track that anymore. Those are the prints. Okay, now we come up here, we run the board. Actually, we just run the board for 2. So let's run the board. Was it 10,000? Is that what the first one was? 2022. 2022. Actually, let's do this. Argument out of range. Okay. Let's get rid of all the breakpoints. Let's figure out where we're throwing. So target X is 1 because the target Y is 1 because Y is 3.9 trillion and the bottom row is 4 trillion. Rows count is 1. Why is that? So less than or equal to still. Oh yeah, less than or equal again. Okay, 2576 is very much the wrong answer. As I recall, 2576. This is like 3068. All right, so let's print the board. All right, so we don't need the board. What we need is we don't need the highest point. We just need to know if we're going to print a piece. Okay. So highest point is going to be the top row. Top row -1 or piece top Y. So let's do this. Max Y. If is set XY. Otherwise, we look to see if the pieces got its thing. Otherwise, we're good. And then we don't need this because we're actually just going to draw the thing on the bottom. Right. So now we're just going to do print. So your print for the piece. Of course, we lost our using for thread. Bizarre. I don't know what that copy was. And here you just got print with a thread sleep of 5,000. See if we can figure out what's going on here. Okay. Those are all starting to look correct. Let's see. Where would you be? You would be... Actually, they're not looking correct. Let's do this. Let's do console read line. So we are going to need to garbage collect a little bit. So, okay, that feels wrong. Let's make these go slower. So we can figure out what's going on here. It's interesting. Okay, so that's 4 up. Okay, so first of all, is it supposed to be 4 up? Okay, so we're 1 off. That's why things are landing in the wrong place. Okay, so we go right, and then we go down, and then we go right, then we go down. We go, I think, right again, we go down, and we go left, and we go down, right? So we go left, and then we go down. So that's interesting. So we print, okay. I think the print is incorrect. Like, I think this should be +1. Why is top row, bottom row minus rows count? That's not right. So that would be rows consumed, which means this goes back to top row. This goes back to top row. Top row -3. That's probably now -4 where it should have been. Let's do 1,000 for these instead of 5. And then every time we print at the bottom, we're going to do top is top row, bottom is bottom row, and then consumed is rows consumed. So none consumed yet, right? And now we're $39.99 with 1 consumed. Okay. Let's do one more. Then we'll compare it against where we should be. Which is right here, which is right here. Okay, that all looks okay. Okay. So I think what we need to do then is get rid of the prints and the sleeps. Yeah, I don't know where that extra print came from. Where did you come from? Ah, right here. So 3068, 3100. Okay. So given that, now we need to do a little garbage collection, which is here we're going to do board. We are the board, right? So this is garbage collect. So the garbage collection this is now us looking for the lowest point of all the data, right? Which, given indexes, those are going to go backwards, which is fine. So the lowest point is going to start as the bottom row. And then index is 1, index is less than rows count, less than or equal to rows count? No, less than rows count. Yeah, less than rows count. Double plus index. So the lowest points, that's what we need, is we need this as an array of 7. Right? And then for everyone here, x is 0, right? X is less than 7, double plus x. And here we're just going to basically say if set for x and our y is max y minus y. So if you're set, then lowest points, this is max y minus y? Yeah, that's right. Actually, we're gonna do this as 0. I just want to do this as indexes, right? Okay, y is set, not set. Let's see. Lowest point is going to be lowest points min. We're going to say console right line lowest reachable point is bottom row minus lowest point. The difference is lowest point. That's all I want to do for right now. $30.95. Okay, let's do this with our old data. And let's run Let's run 10 rocks. All right, let's run 10 rocks and then print the board. Print's not public. Actually, let's not print it there. Let's print it here after a garbage collect. Let's print it and then garbage collect, and then console readline. All right, so the lowest reachable point is still 4,000, 4 billion, 4 trillion, 4 trillion, 4 trillion, 4 trillion, 4 trillion, 4 trillion. I'm worried that we're not gonna cover it up. Yeah, we didn't quite cover it up. Let's run. Actually, we can go back to running as many as we want. Because at some point we should hit it, right? So now the lowest reachable point is here. Should be here. And so you say that's 13. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Because it's here. So that's the lowest point. So if we cut this entire section of data out, we don't need it anymore. Okay. Let's also do this then. So during garbage collect, we're now going to say this. All right, if lowest point is greater than 0, then basically we need to remove from the front of the list. We want to do rows, right? Rows dot remove at 0. And when we do that, then the bottom row has to go down 1. And then the lowest point has to go down 1. Okay, let's run this. So this, we should basically, this is the bottom row we should see. This bottom should go to 87. So the bottom is 87. We cleared out all that data because we don't care about it anymore. We still consumed 21, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, that's right, because this was the floor. So yes, 21 is correct. Okay. So we don't want to print. We do want to garbage collect. And we don't want to print out that anymore. Oh, that's interesting. I wouldn't have expected that. All right, let's keep printing. But I think on print, I want to stop at the bottom row, right? I want to stop at the bottom row. Okay. So that's when we're going to garbage collect. So we garbage collected that. We're going to garbage collect some more because we finally covered up this piece right here. Six, 7, 8, 9, 10, 11, 12, 13. We're going to garbage collect 13 more. That's bizarre because that's going to put us with holes here. That doesn't make sense. At the very least, this could be the last place, right? Because this is completely open. Okay. Something wrong with this logic, right? No. All right. Let me just run it again. Let's see if I can identify it while watching it. So the thing we need to cover is the rightmost. That covers the rightmost. And then that puts us right there. Because it's going to be 14, 14, 13, 13, 13, whatever. Okay. Actually, we should be able to garbage. We should have been able to garbage collect away this. That, that, and that. Long, rock, rock, number, rock. Rock number. So two things I'm noticing. First is when we've determined we can cut 13, it's really, yeah, that's right. We want to cut it there because we want the collisions. So that's right. So that's rock number 10. So after rock number 11, I'm confused why we couldn't garbage collect there because we're definitely garbage collecting incorrectly. string join, comma, lowest points. So right, 0, 0, 1, 1, 1, 1, 0. That makes sense. 0, 0, 3, 4, 3, 1, 0. That makes sense. 4, 4, 6, 4, 3, 1, 0. 4, 4, 6, 4, 7, 1, 0. 9, 9, 0. 10, 10, 10, 10, 9, 0. So there's 4, right? There's that. There's that. We're still at 0. Still at 0. Still at 0. There we topped it off. 14, 14, 13, 13. 18, 18, 18. So there's 13. Now you say 0, 0, 0, 0, 0, 0, 0. You're full of shit. I'm counting from the wrong place. I'm definitely counting from the wrong place. Okay. This isn't max y. This is bottom row minus y. That's why. Cut. There you go. 1, 1, 7, 8, 7, 5, 5, which means we can cut another one. But we're still 0 because these are zeros. Okay, let's stop printing and see if we get the right number. On garbage collect, we're going to stop printing in U to 3068. 3100. Okay. Cross our fingers here, right? Let's go run this against the big giant data set. Okay. So need to run it against that many rocks. All right. Run took a long. All right, let's go. Okay, we're still running. I kind of want to see a little bit of status here. Like every time we garbage collect, I want to say if lowest point is greater than 0, I want to do a console right line, console right, lowest point. Console right line to bottom row. Let's make sure we're actually doing things. Okay, we're making progress. I feel like maybe we just got to keep going. We'll get rid of the console write and write line. The other thing I'd like to see is from a memory perspective, are we getting crazy? So let's sort by process name. I'm looking for day 17. Are you just under terminal? Probably not. I mean, maybe though. Probably nested under Visual Studio, aren't you? Day 17. All right, so we're chewing up a core, but our memory usage is pretty low. Only 20 megabytes. So I'm going to let this run, and we're going to see where we get. Maybe we get an answer. I mean, it is 4 trillion. I don't know of any way to do this faster. I'm sure somebody could maybe figure out a way to do this faster. Like the whole move and match and all that stuff. Pattern matching stuff could probably be faster. You know what? Kind of want to see every. Let's do this. Where's run? If rock number mod 10,000 is equal to 0, how about that? All right, and then we'll do a console write line when we're done. So every 10,000 rocks, we're not slowing down. 1, 2, 3, 4, 5. Okay, let's count time when we go to roll around here. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. So about 7 seconds. Every one of those is 10,000 times 160, right? So 1,000,000,000,000,000. All right. Divided by 10,000. Divided by 160. That's how many seconds it's going to take. That's how many minutes it's going to take. That's how many hours it's going to take. Let's time millions just to make sure I'm not crazy, right? Stopwatch, SW is stopwatch, start new. So let's do 1 million. Console write line sw.elapsed. I don't know how time spans go. SW is stopwatch, start new. All right, so let's see how long millions take. So it looks like 4 seconds per million, give or take, right? Divided by 1 million, so that's a million. times 4. So that's 4 million seconds. That's 666,000 minutes. That's 2,777 hours. That's not going to finish in time. Yeah, that's not going to finish in time. I'll be honest, at this point, I don't know what my next step is. All right, that's what that is it's a trillion. Yeah, I don't know. That's a big number too, right? 1.5 trillion total. Yep, I'm just not sure. So I'm going to end the stream. Another day with, me not finishing on stream, which is kind of a bummer. Yesterday, I sort of figured it out not long after. I am not confident that I can actually finish this. I'm going to have to do some pretty extensive sort of Googling to figure out how to do this. I don't know how to do this any better than what I'm already doing it. I mean, obviously I could do, let's go look at the code real quick. Right. The board could be, instead of a list of Boolean arrays, right? This could be a list of bytes. All right. I don't know if that's not going to be any faster. The mask here is going to be x. It's going to be 1 shifted left x. And then we're going to say return rows at int target y. And mask is equal to mask. And you're mad because you can't do byte and bool. Between byte and bool, rows is a list of bytes. The mask is an int. Oh, yeah, parentheses. Parentheses required. So there's that. Let's do this. If false, else, and if. All right, and this was this. So we'll do if false, else, and if. I doubt this is going to be any better. List of Boolean array. Rows is a new. New, true, 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 true. 1, 2, 3, 4, 5, 6, 7, right? That's what that was. And then set, and then we need set. Set is the other place we need. So we have this, else, and if. We need to fill rows if they need to be there. So we add 0. And then we say rows int target y. We need to be that. We need to or equal the mask, right? So we need the mask from isSet. Can I convert it to a byte? Byte. That should probably be true for this as well, even though it didn't yell at me about it. Is that going to be any faster? Not really. A little faster. Not enough. Yeah, not enough. Okay. Now I'm pretty sure I'm done because I really don't know what else I could possibly care about here. Maybe if I garbage collected a little bit less often. Let's try that. So let's say if rows count is greater than 100,000, is less than 100,000, then don't care because 100,000 rows is fine. Saves some time. I mean, we might be able to optimize that a little bit more. What if it was 10,000? All right, we get a little bit faster. What if it's 1,000? Because obviously what we pay, that's looking pretty small. It's looking about as small as it can get, but we're still calc. We still have 1,000,000 times 1.4 seconds, which is still 23,000 minutes, which is still 972 hours. Right? Not enough. Not enough. We need to somehow make millions of moves in milliseconds. And this is not the strategy for that. So, all right, well, I guess that's it for today. No idea whether I'm even going to get the second star or not. See y'all tomorrow.